This
I'm okay.
conference will now be recorded.
You good? We're ready when you are. Okay. We'll call this City of Sedalia work session on April 25th, 2022 to order. I believe we have Cliff Cate here from Burns & McMullen. He'll take us through the wastewater master plan.
Good evening. Thank you, Mayor. Appreciate it. Council, thank you very much for having us this evening. I want to thank you for the opportunity for us to come and present the draft report for our wastewater master plan. So first of all, I want to say thank you to the city for the opportunity for us to do this. We've been working on this for the past year. I'd like to say thanks to the Public Works Department, the Planning Department, the operations. When we talk about master planning, we're really working with every department with the city. Very collaborative. Actually worked with operators this year out in the field too. We worked at the wastewater treatment plant, went to visit them. So very partnership with the city. So we appreciate everything that you guys have done. So over the last year and a half, we've had the opportunity to work on this wastewater master plan. And tonight we're going to present our draft report for that. Our findings, go through the process that we did. And we're really going to break this up into two different parts. One, we're going to talk about the wastewater collection system. And then two, we're going to talk about the wastewater facilities. Collection system meaning all the linear work, the pipes, facilities meaning your three wastewater treatment plants. So with me tonight, oh, sorry, I guess I got the clicker. So my name is Cliff Cate. I'm the project director for the wastewater master plan. With me tonight, who's going to be speaking is Rochelle Lowe. Rochelle's going to be talking about the collection system work. Jeff Barnard and Caitlin Prim are here. They did the wastewater facilities evaluation. Talk to you a little bit about that. And then Brian Kinzineri couldn't make it this evening. He ended up sick. But Brian's our construction manager. He was going to talk about constructability and some of the safety issues that go along with working out in the wastewater field. So for every meeting, we like to start with a safety moment. And we thought this would be a good topic just because we're talking about wastewater. And you know, operators always work in this atmosphere. It's a hazardous atmosphere when we're talking about in a collection system field or at the wastewater facilities. So there's a lot of things that are out there that you need to be made aware of. And when we go visit wastewater facilities, we're always mindful in what we're looking out for. And at wastewater facilities, you have a lot of chemicals out there. And those chemicals can be from the actual wastewater, where you have methane gas, you have hydrogen sulfide, so you need to be very aware of it. But you also have chemicals that treat the wastewater treatment or the flows too. So those are kept there at the facility. So you need to be aware of where they're located and be aware of how to handle that if you do come into contact with them. So know where your chemicals are located, know what to do in case of an excursion. So if there's a chemical outburst or if somebody gets exposed to it, what do you do? So you need to know what happens in that case too. The other thing, you need to be aware of rotating equipment. So out of the wastewater facilities, you've got belts, you've got pulleys, you've got pumps. So you've got a lot of equipment that's operating that you need to be aware of. Make sure you avoid that. And then be aware of access and egress. So when we talk about handrails and even footing while you're walking on our wastewater facilities, these are all hazardous conditions that the operators face every single day. And when we're out there, we need to be aware of it too. A lot of equipment in older facilities, they had codes that you met codes maybe 30 or 40 years ago that may not meet the same codes today. So you have to be very aware of where you're walking and all the safety that comes along with that. So as I mentioned, we're going to break this up really into two different sessions. And obviously, I want you guys to stop us if you have any questions as we go along. But the two different processes are the wastewater collection system, which is the pipes that get you to the facilities, and then the facilities. And Jeff's going to talk about the facilities. But Rochelle's really going to start us off, talk about the process, how we got to where we are today.
Thank you, Cliff. So like Cliff said, my name is Rochelle Lowe, and I'm the project manager for the collection systems from Burns & McDonnell. So thank you for having us tonight. I'm going to walk us through the master planning kind of roadmap, where we were at from the beginning and how we got to where we're at today. So there's four basic steps that we go through to review a master plan and develop those capital improvement projects. But really the goal of hydraulic analysis and master planning is building you guys a model that will really replicate your existing and future conditions within your system. So what I mean by a model is a hydraulic model that you guys can use as a tool to really help develop a plan for your existing system, and then a plan for future development and how you're going to handle that for the years to come. So ultimately, we really want to give you something that is executable, that you guys can actually execute, and base it on not only like years of projected development, but also triggers. What can trigger these capital improvement plans? That could be future development, it could be regulations, or a variety of different things that might trigger that. And we want you to be able to use this model to evaluate that trigger and then decide what's the appropriate capital improvement plan that you would need to initiate. So we're going to start with what we've learned so far. So there's 4 basic things we're going to review with you. We're going to break each one of these down. So we're going to break down first the data review. So ultimately, you guys have a lot of good information already at our hands. And we really want to utilize that information that you have. We got from your operators and your team and from Brenda, all that information to really build that solid foundation and understanding of your existing system. So we're going to start with the basics. What do you have? What your existing system consists of? So this is a map of your entire wastewater collection system. The black lines on this map are representative of 733,000 linear feet of collection sewer mains. So that's approximately 140 miles. Basically, it'll take you from here almost to St. Louis if you laid that out, in a straight line. So that's a lot of sewer pipes to maintain and operate, every day. So in addition to your collection sewer pipes, you also have 15 lift stations. So that's some of that mechanical equipment and electrical equipment that Cliff was talking about before for safety, are your lift stations. So up on this map, those little like round dots with pipes coming out of the ground, those are representations of your lift stations. In addition to your lift stations, you have 4 equalization basins. The equalization basins kind of look like little ponds up there, or pools actually. And those help to regulate the peak flows that are coming into your system and help to regulate those as they then flow into your downstream wastewater treatment facilities. So you have 3 wastewater treatment facilities. Sedalia is kind of unique in that they sit kind of on a ridge, and your city flows in different ways, topography. And so you have 3 wastewater treatment plants to help address that. And so you have lots of assets, lots of different components that are being operated and maintained and to evaluate. So additional, after we understand kind of what you have, how are we going to assess this and what information do you have available? So you had a lot of previous work that's been done, and we don't want to discount that. We want to review that and really build a solid foundation to simulate what your existing system, how it operates, and kind of replicate what's going on in your system in the field to what the model results show in the hydraulic model. So we looked at as-built. We had several meetings with your operators and your maintenance crews so that they could explain to us how flow enters into the lift stations or enters into those EQ basins, how they maintain that and regulate it as it moves downstream. Also, you've done a lot of work for past like sewer rehabilitation work. So we wanted to understand how that impacted the system and changed the system over time. And also you've done a great amount of work just building your GIS network. So what's GIS? It's a database of your assets, and it really categorizes and catalogs what types of pipes you have, what's the material and sizes. And so we used all that information and started to build our model and look for gaps in that data. Where were there potential areas where maybe it didn't quite make sense with maybe different types of assets? And so we worked with your crews, Brenda and Dave, and they went out and helped us resolve those issues because, like I said, the goal is really to build this model that replicates what we know is going on out in the field. So here is a representation of that model. So this is your tool. The city owns this model. And up here where the aerial picture is how we brought all this information into the model. And then the picture on the right-hand side is a sewer profile pipe. So it's just an example of what the pipe, like making sure it flows downhill. And that is what you have in the model. And that's really your foundation to the beginning of building your master plan. So now we're going to move in. Well, first, any questions on that? No? Okay. So next, after we have that solid structure foundation of all your assets in the model, we really need to now build the flow into the model. So we start our hydraulic analysis piece. So the first component of hydraulic analysis is the flow metering. We installed 9 flow metering devices throughout the city. So this map is a representation of how we broke out your existing system into measurable flow areas. We started flow metering in May of 2021. Like I said, we installed 9 flow meters and we metered for about 60 days. The reason why we meter for a 60-day period is because we're really trying to capture that different type of flow within the system. So the dry weather flow, so what's your average flow that you're seeing based on just a kind of a daily average, and then also looking at what the wet weather, so when it rains, what happens within your sewer system and how does that rain event affect the capacity of your system. So we utilize all this information to develop those flows in the model. So kind of wanted to break out for you guys when I say dry weather and wet weather components, what those flow characteristics really look like once we get that meter data starting to come in, what that looks like. So there's really 2 components of flow within the system, and that's that dry and wet weather. The dry weather flow you can see on this graph is within the blue, and it has its daily peaks. It peaks twice during the day. Usually that's our diurnal curve. And then we have wet weather, and that's that red peak. So you have initial inflow that gets into the system from various sources, and that creates that kind of initial peak and takes up a lot of capacity within your sewer system. And then you have infiltration, which after the storm event is gone through, the ground is saturated now, and that water starts infiltrating through the ground into defects within the sewer pipe. And that's the components that by installing those flow meters, we can break that out and really start to understand maybe where those capacity needs are for your system. So I had mentioned inflow and infiltration. And this is a graphic really describing how that inflow and infiltration gets into the sewer pipes. And there's really 2 main sources of inflow and infiltration. There's the public side and the private side. And on the public side, you can get inflow sources from maybe unknown stormwater connections, inlet grates that might not have been disconnected or connected unknowingly into the sewer pipe. Defects in the pipe joints, just through time they've settled and created areas where water can get in. Then on the private side, you can get inflow sources from downspouts or open cap cleanouts or infiltration through roots in the service laterals that then create a source or a spot for that infiltration to get into the system. So that's how those different components of the flow can get into your system and how it reacts, the sewers react. I kind of just wanted to show you a result. Like I said, we did 9, so I won't step you through. If you guys got the master plan in front of you and printed off the appendices, they're all there. All the results are. But I want to kind of step you through what that looks like on one of these meters. So this meter is in the northern section of the city. It's located just south of 65 Highway and, south of Grand and by 65 Highway. So this meter captured flow for, like I said, about a 60-day period. And the green up here is that flow rate that I was talking about. And it kind of shows that normal, the normal diurnal curve kind of going up and down on an average day. Then at the top here are these black marks that indicate a rain event. What I failed to mention before too was that we not only install flow meters, but we also install rain gauges so that we can understand that when that rain happens and correlate it to the response in the flow meters. So at the top is the rain gauges, and when it rained, and you can see at this meter, there was a response in the flow, especially during this late June rain events. And so the flow is pretty normal, and then peaks, gets that high inflow peak, and kind of takes a couple days or a couple hours to kind of go back down to normal, and then peaks again. So we know in this system there are some sources of inflow and infiltration, I&I, that are getting in this area. So we did that flow analysis on all 9 meter sheds that we had installed the meters in. And our goal was really to evaluate where the most I&I was being seen in the city of Sedalia. And so this map, the red, the darker red is the highest inflow and infiltration, and then the yellow is the areas that have the least. So the south area, you can see, is all pretty yellow. And that's due from, like we said, we did all of that kind of review of past projects and data that you had available. And a lot of your previous I&I work was done in these south basins. And so we can see that has helped alleviate some of those I&I capacity issues that we're seeing. But the main area where I&I is being an issue within that central area. And so that area is kind of bordered on the north side by Main Street, on the south side by 16th Street, and east and west, State Fair Boulevard, over to about like Carr and Grand. You can see on the west side it kind of moves east and west a little bit, but that's a general area. And that's really your downtown, oldest area of the city. You have the oldest pipes in that area, and so these are areas where you potentially have some more sources of inflow and infiltration. Any questions about that?
You got any ideas on where that's coming from in that center section of the city?
Well, I know like Brenda and team has done a lot of smoke testing and CCTV. We haven't started to review that, but that's one of those things that we'll start to look at is reviewing those assessments of those sources eventually.
Right, and so $150,000 irrigated pipe that we've been doing each year. That's pretty good. Much they can do in that red area.
But then this study was really after that.
$150,000.
Done.
It's a start. It's a big start, especially after 5 years. There's still a lot of pipe.
Yeah, so definitely a good start. And we'll talk about some costs later on, and you'll see some of these. This is one of the pilot areas we'll talk about, piloting a reduction, like inflow and infiltration reduction area, and seeing what those sources are, how much it takes to remove them, and what that dollar amount could be. So, and then being able to apply that citywide and get a better understanding.
Do you have any idea how many gallons of inflow and infiltration are coming from this specific area per year?
It's in the master plan. I don't have the number off the top of my head. I can get it for you later.
Yeah, we can estimate that. One of the tricky things is it's all pertinent because of rain events, right? So it all depends on how much rain you get per year. So, and we're measuring on a 60-day period, so we can kind of project out maybe what's happening that year. Or Rochelle's going to talk to you about a design storm event where it kind of standardizes, what you're looking at. So like a 2-year design storm, how long that occurs, and how much I&I you'd get from a 2-year event. So she's getting ready to talk a little bit about that. But that's kind of how we look at projecting your I&I and how much should be taken out. So.
Yeah, so like Cliff mentioned, after we do the flow analysis at those flow meters and start to project the flow in the different areas, our goal is to really calibrate the model now to those known flows to look at it based on design standard storms. And that's what Cliff was talking about on these different storm events. So we want to evaluate, really, we looked at these 3 different design storm events, and these are industry standard events. And each event has different intensities and total rainfall, which impacts your sewer system's capacity. So the bigger the event, the less capacity you'll have in your system when we're evaluating that event. So the 2-year is your more frequent event. And when I say bigger event, that's your 10-year. It's your less frequent event, but has more total rainfall during that event and higher intensities. So therefore, it stresses your system more for those bigger events. And like I said, the goal is really to find that event. So we want to analyze all 3 of these and look at how your system responds and find the event that really provides a level of service appropriate for the city of Sedalia. So this is an example of running all 3 of those events. So hopefully this might be a little hard to see, but these are the manholes level of service. So we ran all 3 events. The 2 is the red, and you can see a lot of those dots have red indicated on them, which means that there's a potential at those manholes for surcharging. So for the sewer potentially be coming to the top of the manhole or potentially out. And then the orange is the 5-year, which builds upon it. So it's the red plus the orange, and then the 10-year is all of the colors. So in a 10-year, you can see how that really starts to stress your system. And then we move to the pipes, which this looks daunting. But like we said, we're looking at all 3 events here. And so, again, the 2-year event is your smaller storm, and that's your red. And then as you build it on, bigger design storm, you start to see how your system has less capacity to handle those flows. And so we want to pick a design storm that will fit your budget and improve your existing level of service for that design storm. So in conjunction with discussions with the city, and we decided to move forward to evaluate your system based on a 2-year event. And that 2-year event maximizes your existing system's current capacity and helps us develop capital improvement plans that can really work with the available budget that you have. So,
Can
yeah.
I just cut? Okay. When you're talking capacity here, you're just talking collection systems. You're not talking plant, right?
Correct. Right now, we're just on the linear collection system.
Okay.
Yep.
And then how did you set that budget number?
Well, so the budget is we look at the 2-year storm and try to say, okay, the more improvements that you potentially have at the higher event, the more capital improvement budget you're going to need.
Okay.
And so the 2-year is your more reasonable budget
Okay. So
improvements.
Okay, I misunderstood what you were saying. So basically, you're letting the 2-year event drive what the budget should be.
Correct.
Not what the budget should be, and then come back.
You said it right. Yes. Thank you for clarifying.
Yeah.
Yes.
Okay. Just making sure I understood. Thank you.
Yep. So this map indicates the existing conditions. And right here, I listed just a couple of the things by looking at this map where we see potential issues that we want to start to, we'll talk about as we get into the capital improvement plan, what that project might look like to help address that. So you can really see, again, in that central area, a lot of the pipes are red. So one of the improvements that can be done is potentially an I&I project there. So that's, we looked at what would be the effects of a 30% reduction in I&I. So trying to address that total volume and reduce it by 30% in the central basin. And then we saw some issues with pump stations. So some of the pump stations are constrictions within the system that cause that backup upstream into the pipe. And then also just general localized issues are there too within the sewer system. So up here in the map too, just kind of wanted to show you guys what your average daily flows are at those 3 points within the system. You know, we said we had the north, the central, and the southeast areas where your sewer systems flow. So just kind of, we'll go back to these numbers as we get into the future conditions and how those affect the overall flow to those 3 main points within your collection system. Any questions or anything I missed?
I have a question about stormwater. We're handling that in the Liberty Park area. How will that affect stormwater renovation? How will that affect this Liberty Park area? What about this area? Since we got plans to.
We need a 7 part. We're talking
Stormwater drainage issues they have around Liberty Park, how will that affect this?
because several years ago, we actually did it. So we either have stormwater pipes or you have sewer pipes to get out of. Now, the only thing that I still think we may have issues with is the point at which you've got standing water in roadways, which we know we have, and there's definitely issues with that.
Oh, yeah.
And so I think that in the Liberty Park area, we need to look at.
You can reduce that standing water, potentially reduce that inflow. Yeah. Okay. So we've created the model, and we know how your existing system is functioning. And we've looked at, we know where there are some existing issues. What we need to do now is really incorporate future conditions, which includes, really understanding where the city wants to continue to grow and develop, and where the city anticipates that growth to be, and where those connect into the existing system, and does it have any potential impacts on that existing system's future capacity. So here we began with your comprehensive plan. I know you guys have been doing a great deal of work with the comprehensive plan, and so we don't want to recreate that. So we started with the comprehensive plan and really overlaid that on top of the existing conditions model that we have. And we started to, that comprehensive plan really lays out what type of developments anticipated there: commercial, industrial, residential. And so there's standard flows per acre that we start to project into those different areas so that we can find and calculate that total flow that's going to be added. And so we also knew from discussions with the city and Brenda that there's potential for large water users, especially in that north area. And so if you're a large water user, you're probably going to have a large sanitary sewer use. So we also added that in because those have a significant effect on capacity within the pipe, sizes of the pipe, and then that downstream load. So that work, we calculated flows, and we're able to determine what that future average daily flow was going to look like for these areas. Up here, I've really concentrated on the north and the central. The southeast area, the development in the southeast area really was kind of negligible to the overall flow that we were going to see in the future. But we saw, like you can see up here, almost 3 times, the average daily flow in the north. So existing is 1.1, and in the future, once that is fully built out, over the next 20 years, it will add up to 4.8 NGD to your existing north system. I've kind of put locations of your treatment plants up there so you can kind of see where those are at, and Jeff's going to get into that later. But then in the central area, there's also some industrial future development anticipated there. And there's, some large water users also. So that's going to increase that flow to almost another additional 1 MGD, so up to from 1.9 to 2.7 MGD. So there's a need to look at future improvements for this additional flow so that you can serve that future development. Chris?
So we just want to pause real quick and see if you guys have any questions in regards to that. So Rochelle really went over the development of the hydraulic model, right, which is really the tool that you use for master planning. And that model was developed to simulate as close as we can how your existing wastewater collection system handles flows right now, but also future flows. It also handles what type of storm event may occur. You had a great question, Mayor, about how much rainwater do we get into this? Well, what we try to do is project out on certain design storm how much rain would get into it, and we ran the model for that 2-year, 6-hour storm event and showed you how much capacity or the capacity that's needed in your existing collection system to handle that type of rain event without surcharging out of the manholes. So that's what we ran. We looked at now the future flows, and that's based off the comprehensive plan where development's occurring. How much flow is going to be generated from that future growth and how it affects your existing system. In the north, you really don't have any collection system up there, so it's not affecting the collection system, but it does affect your facilities up there. In the central, it does affect a little bit in your collection system, but mostly the central plant. So as I mentioned, we started out with, we've got 2 parts of this presentation. The first part's really talking about your collection system, the linear work that's involved in it, and then Jeff's going to talk to you about the facilities. But the next steps, we're really going to talk about the capital improvement projects that are associated with the collection system. Again, based on existing conditions, when we run that rainfall event, what do you need to improve your system to meet or to be able to handle that flow and keep it inside the pipes? That's where we're going next.
Let's go through the 2-year, 5-year, and 10-year.
You bet, you bet.
And because when Kelvin asked about it, I thought I understood it, but
Yeah.
So if we're going to prevent a 2-year event, that'd be the highest budget level, right?
That's the lowest budget level, sorry. So a 10-year storm event.
Okay, yeah, 10-year storm.
Yeah, 10-year storm, theoretically, they said happens once every 10 years, right? But sometimes it happens more often than that. And with that, that's a very heavy rainfall event. You're getting high-intensity rain. It goes through your system. Your pipes can't handle a 10-year event. So when we run the model, it says you need, okay, you've got an existing 8-inch pipe. A 10-year storm event may say you need a 36-inch pipe to keep all that flow in there, right? And it's not just one pipe. You need it all the way down to be able to keep a 36-inch in.
It's the volume, not the years, really.
Exactly, yeah, a 2-year.
Problem every 2 years. I got you. Okay.
Yeah, so it's a smaller event, smaller volume, and a smaller intensity event. So a 2-year may say, hey, you still need improvement, but maybe it's a 12-inch. The other thing we looked at is, okay, let's run this model without doing any I&I reduction, right? Let's just say if you don't do any work in your collection system to take the I&I out, how do you handle that, right? So that's where you get maybe a 36-inch pipe. And then we say, okay, now let's take 30% of the I&I out, 30% of that wet weather event out because we're going to do some repairs. Now what does it look like? So it may take a 12-inch pipe that you decided that you were going to have to build and may reduce it down to a 10-inch. So it's not saying you don't need the improvements, but it's just reducing that.
And then the red zone, that's our problem zone, is primarily the drainage for the central plant. Is that a fair statement?
It drains to the central plant.
Yeah.
Correct. So that's the one that has the most I&I. So, we did the flow metering, and I may add that we put 9 flow meters in, and we actually used the city's meters to do 3 of those meterings. So trying to save some costs, and we actually used the field crews from the city to help do the metering, which was awesome. So again, it was a great partnership. But what we did was we ranked each one of those basins after we metered to say which one has the most I&I or the worst conditions, right? And the central plant was out of those 9 basins, that was the one that had the highest flows.
I may be premature in asking this, but as you go through and do your analysis, do you do like comparisons between okay, it would cost you this much to put a 36-inch pipe to put it in, or it cost you this much to reduce the INI.
It's a great way to look at it. And EPA uses that. It's called the cost-effective analysis curve. So, yeah, we do look at the capacity of that. And then the other thing you look at also, Kelvin, is, okay, I've got, I need a 30-inch pipe. I can do some INI reduction. How much improvement at the plant do I need to make?
Mm-hmm.
Right? There's a balance in between all of that to decide this is what we need to do that makes what's cost-effective to do. So,
yeah. But
right.
Am I correct in it's unrealistic to eliminate all INI?
Absolutely.
Okay.
Absolutely. I wish I could say, yeah. And I think we can put a number up there to eliminate 100% of your INI, but I don't think it's going to be realistic in any way. But the thing about INI is it's pretty elusive. I mean, you guys should know that by now with the CSO issues, and you did the disconnects and you did this, and it's always going to be there. And whether you solve it in the public sources and you do line every single line or line every manhole, you're still going to have some issues because you got private sources as well, and you've got downspouts that can be disconnected. You got mobile home parks. When mobile homes get pulled away, they are an extreme culprit for inflow and infiltration. So you're always going to have those types of issues around there. The best you can do is do your repairs now, but just keep looking at it, right? It's something that you always have to take a look at. So,
How much, do you have any idea how much INI comes from the house side of the system?
we did not break that out. It's a great question. We've done some other studies in the past where we've done private INI projects versus public INI projects. I can say it ranges anywhere from 40 to 70% of the INI is coming from the private side. So it's quite a bit, and the issue, I think and you're starting to see a little switch. You're starting to see a little switch in this where a lot of cities have concentrated on the public INI sources because that's what you own and maintain, right? And so you're spending your money there. But the cost-effective sources to remove are on the private side. To fix a downspout or an uncapped cleanout is pretty cheap compared to lining a whole line segment or doing a manhole rehab. But it's just one of those issues that if you're ready to take that jump, then
So that's my last, and that leads up to my last question. I grew up in the red zone, so to speak, and a whole bunch of that's the old tar, and those laterals that are going from the house to our main are the most notorious laterals for.
Probably got Orangeburg pipe or truss pipe.
Almost right down that entire area for the simple drainage. So are we pouring sand down a rat hole trying to fix something that's really not the problem in the red zone anyway? I mean, do we need a program to help the homeowners fix their 4-inch lines feeding in?
The laterals.
I don't know if we can make that analysis. Brenda's probably got an idea, but or Dave.
I could say you've got 140 miles of collection system mains. You probably have 100 miles of service laterals throughout the city. So it's almost 50-50 when you look at those types of lines that you're talking about, those service lines. So.
And it's pretty concentrated housing in small lots, so there's a whole bunch of house laterals down through that whole red zone.
Houses that are no longer there, where when the houses were taken down, they did not flood the open sewer. So we try to find those as we come across.
Do those show up with smoke? Can you smoke those out?
You can also see when you televise it, when the cities televise it, you could see some of that active INI, I'm sure, coming from those types of sources.
Yeah, that makes sense.
Yeah.
My question is, in looking towards the future, if you possibly could right now, what grade would you give the system that we already have? And with following your direction, following your plan, what grade would it bring it up to and how long?
Oh, boy. That's a tough question. I'm not sure. Sedalia is not unlike most cities of its age. You have you'll hear the term aging infrastructure over and over again, and Sedalia falls into that. You've got a system that's been around for over 100 years. You've got pipes that have been in the ground that you're finding right now that are crumbled. You may have wood pipes in your system that are operating like water mains. So you just have an old system, so it's hard to put a grade on it. I will say that, you know, ASCE on an annual basis puts out a grade on United States on their infrastructure, and they grade each piece, you know, whether it's the streets, the water mains, it's the sewers, and I think they continuously grade the sewer system as maybe a D+ or a C-. So when I say that, that's, you know, I'm not sure I can put a grade on it. You know, one thing we can do is compare maybe your peak flows. You know, when we did the flow monitoring you were asking about, Councilman, and, you know, we look at the peak flows, and the peak flows are from a standard dry weather flow, and then that peak inflow, what's the peaking factor there? So if you had a 19-to-1 peaking factor, which means that on a rain event, your flow that was at 1 MGD went to 19 MGD, that's pretty bad. And so I think you're probably somewhere in between there. So we could do some quick comparisons to other cities when we look at flow metering, but I think it's just going to vary. I hate to give you a grade and then tell you it's going to be a better grade. So,
But taking into consideration that I believe come October this year, today will be 162 years old.
yeah,
They're telling how old some of that pipe is in the ground.
probably 162 years old.
Yeah,
a
you're
lot of it. So yeah. So, but I will tell you, you know, it's you know, when you're removing I&I, the piece, you know, when we talk about doing repairs and improvements, we're not talking about doing structural repairs. So when we give you a cost estimate to say do I&I removal, we're not saying just go fix the broken pipe that you televised, right? Because sometimes that may not be an I&I issue, it just may be a broken pipe. We want to make sure that you're repairing the right pipe in the right place at the right time, because our goal is to remove that I&I and give you capacity back into your system and actually maximize your asset, utilizing your asset more than anything. So it's about being strategic. And I think, you know, I got to applaud you on doing your master plan, because that's what master planning is about, is being strategic on how you handle your existing system, but how you handle growth. So you're doing the right thing by looking at this and developing a plan, and whether that gets you from a C- to a B+, I can't answer that when we're only talking about removing 30% of the I&I. So.
All right, so houses that been destroyed or torn down, if a new home is built there, they can't use the old sewer line, right? They have to put in a new one.
Historically, that's been the case. In some areas now, you would have, come down at a younger age, where there's been a clean out put in, so that we can kind of track where the flood pipe is at, but you always have to re-camera everything to see the condition of that pipe. When they demolish the house, frequently the manner in which it is demolished crushes the balance service line. So our goal is to have the cap in place that it's dark so that they don't cause problems.
And I do know there's some cities that implemented on the sale of the house that it's required to televise the lateral. So that's that line going out to the main line.
That'd be an ordinance or something we could require, and you could have something that we could require with demolition.
It would be a good discussion to have some of your local realtors with too, to have that conversation. So.
I don't know if this is the place to ask this question, but data collection is going to be important going forward. Are we going to do anything in these new systems to improve connectivity at places like lift stations and manholes and forces, so we can monitor things instantaneously? Or could we do that now? Is that something that So we basically got data collection. You're satisfied with our data?
No, that's a different question. we are, poor Kellen has been very patient with me because I got here and he was not too far in front of me coming. And
flexible.
I just want to collect more data that would give me more hints as to where the INI is. But I want to do it cost effectively, so.
Yeah, I think you all approved here a year ago, maybe? It hadn't been that long ago. The new system, the new software.
The software that we got approved is for continuation of these models, the hydraulic models.
Yeah.
So we can take the data as a capture and continue to work.
Yeah.
You're collecting data at every water meter, right, essentially, so you know what's going in.
But everything that goes into
Mm-hmm. And more comes out than goes in. Yeah.
Well, that's, yeah.
a lot of the, we've got a lot of industrial plants that are listed as percentage of the water factor. So there's a lot of factors that we have to monitor. And a lot of those industries that are coming in now are willing to monitor their outflow so that we build on actual outflow instead of averaging anything. So, you know, that flow meter out is important to us. So we've been working as industrial come in to get those meters put into place so we can watch the outflow.
Okay, I'm happy.
So, as we go forward, Rochelle's getting ready to talk to you a little bit now about capital improvement projects. And as we talked about, the master plan really starts with building the hydraulic model and then running different scenarios, what we call, you know, different rainstorm events. And then we come up with a list of projects that need to be done over a certain period of time. One of the things that we talked to Public Works about early on, and Kelvin, I think we mentioned to you too, is when we do master planning, we don't necessarily say you need to do this in the next 5 or 10 or 20 years. What we say, we look at trigger points. When this occurs, and when this growth occurs, and when this regulation occurs, you need to be doing this. You need to move in this. So as we move forward, Rochelle's going to talk to you about maybe a couple different phases of capital improvement projects. There's some that need to be taken care of early, and we'll call those early action or phase 1 improvements, because the INI issues that you have right now, you need to be addressing some of the INI issues. But 2, you got some future growth coming in as well. So these things need to be taken care of. So we're going to call those this early 0 to 5, possibly phase 1 improvement. So she'll talk through those with you, and then we'll pass it over to the facilities here in a second.
Thanks. Okay. So this is a map of the potential proposed capital improvement projects for the existing and phase 1. So like Cliff said, we don't like to put years to it, but we do like to kind of, the phases are kind of based on a potential years so that you can kind of plan for that. So this map looks a little daunting. I don't expect you to be able to read the labels and really see all the details. But what I want you to take away from this map is that there's existing improvements. So your existing system, without any development, if development were not to come, the projects that are labeled in red here, the pipes areas that are labeled in red, those would still need to be addressed because those are existing issues. And so we'll go through that. I'm going to break this down. We're going to go through some more slides and talk about what the existing issues and capital improvement plans are. And then the purple areas up here, those pipe systems, are for that phase 1, which I'm referring to as kind of like a 5-year planning period. What we expect to potentially anticipate growth in those areas in the 5 years. So you can see in the north, there's some in the south, and then in that central area that we talked about. So that's adding additional new construction, new pipes to help facilitate that anticipated growth. So here is the existing system INI reduction needs. Like Cliff said, we know that there are some INI that need to be addressed. So we talked through, you know, that you guys are already doing a lot of assessments, smoke testing, CCTV. So the first thing is really to put together an INI reduction program that helps you not just go in and line pipes because they might be failing, structural issues more, but try to look for the areas that will help maybe achieve that 30% overall reduction, so that you can decrease then that potential need for additional new pipe or remove and replacement of pipe in that central basin. And so we've proposed to create a pilot project in the central area. So I know, like, you were discussing that, how do we know where those are coming from? Or, can we do enough in this area even to achieve 30% reduction?
I guarantee in that area, there's a bunch of 12-inch plate pipe that are the lateral for the house, and,
right.
They may, if we're lucky, may have tar paper every 12 inches 50 years ago when they were buried.
Right.
So there's a whole bunch of infiltration coming on the house side.
Coming on that private side.
If it's not that, it's the old tar paper pipe, there's not a whole lot of plastic in that red area.
Oh, yeah.
Coming from the house over our main.
And so your understanding of the system is shown, really, you've represented up here of what we saw. And I think the part of the program, developing a program and having a pilot area so we can assess what's coming from the private side. We can break that down where we weren't able to as part of this master plan, but we can assess what's coming from those different areas and see if we can even achieve on the public side a 30% reduction, or what's more realistic, is it, more or less?
How do you make that assessment without really going and verifying, or ask Dave or somebody that's actually been in that area, hey, if I'm actually right about the private side?
Yeah, well, they have done a lot of smoke
Is there
testing.
any kind of program in the nation where they actually help improve the private side?
Sorry. Actually, there are multiple programs out there that are doing it. But when you talk about a grant program or a SRF, I'm not sure if they're hitting the private side yet. So a lot of cities have moved towards that. There's a couple different ways that they're doing a private I&I program.
Okay.
City of Kansas City is doing one right now where the city's actually paying for all the work to be done on the private side. There's others, Johnson County Wastewater did something similar, but some other cities do a reimbursement policy where the homeowner pays for it and the city reimburses either 100% or a portion of it back. And then there's other cities that are more, you got the carrot or the stick, and they're more like, you need to fix your problems or we're going to shut you off or something like that. So there's various programs out there. There's a lot more that are going on in the country. I haven't seen any grant programs out there to help pay for it, but I think the most successful ones are where the city ends up paying for it because their system's being affected by it. So I think the pilot study, I think with
I think the pilots, I agree.
That's where we get a good indication, and especially if you're saying that it may be the laterals up here, that's a good way to indicate what that is in the other areas, so we can kind of look at those defects. And I know, Kelvin, you said looking at a cost-effective analysis. Well, we can't do that without knowing what the defects are, and then we can put a cost to remove those and how much flow we remove from each one. So that's kind of the purpose of the pilot program, and to establish an overall plan for you to attack I&I going forward.
So my purpose was to kind of put a bug in the air, and I think we're on the same page.
Absolutely. That's it. Yeah, absolutely.
That's great. I didn't mean to
No.
stop your flow.
No, you're not. And I wanted him to come up and interject, so perfect. And so, those costs on the pilot areas, those are all going to be determined just based on getting out in the field and really finding it. And so those costs might not be the true cost once we get out there and see what's actually out there, and versus private and public, and how we deal with that. So then moving into the existing systems, like I said, in that map that you saw before, the red areas were indications of potential capacity issues within the existing system. So you can see here there's quite a list, and I'm not going to go through each individual one, but in your master plan, the capital improvement section has a really good list of each project, what's entailed with each project, how many linear feet of pipe, and how those costs were developed. So, what I did want to do is point out these four that are highlighted in blue. The reason why I highlighted these is because these are what I would consider more near-term potential projects, because they're located downstream within the system. And usually with sewer improvement projects or sewer projects in general, you start at the downstream and you try to provide capacity down there, and that helps alleviate some of the upstream issues, and then you keep working up until you fix it. So these projects, the central plant, relief sewer, there's some restrictions by the central plant that are causing some backups upstream, and that's in that central district again. And so when we start alleviating those issues downstream more, hopefully then we rerun the model, recalibrate it, and see how that affects stuff.
So a relief sewer basically gives us another place to drop the water in the manhole.
Yep, so a relief sewer, so when we put up here a relief sewer, that can be a combination of remove and replacement or a parallel sewer system. It can be, kind of what makes sense in that area just based on the infrastructure and restoration, all those different needs. But for right now, to price it out, we really just looked at a parallel system and what that potential cost would be. So again, most of these improvements that I have highlighted in blue are relief sewers to add that additional capacity. So we bring that water surface elevation down in the sewer system and keep it about 3 feet below the manhole rim surface, because that's just is giving you a safety factor. So in those bigger events, you have less chances even of it overflowing in those events. Any questions? So now, like I said, that map that we're looking at has the future plan. And we're looking at kind of a 5-year time frame, and in conjunction with, like we talked about, your comprehensive plan, we know a lot of growth is going to happen up in the north and there in that central area. And so these are the conveyance linear sewer pipes that would need to be constructed to help serve those areas. So up in the north, we have proposed a gravity sewer system that would flow to a lift station and then be pumped over to the north treatment area. And in the central basin, some additional future flow. These projects right now there's some improvements going on in this area right now, but so there, and then in the south, some additional projects. So those are made up of about 5 projects to help continue to grow and service those new areas that are going to come online over the next potentially 5 years. But like Cliff also mentioned, it doesn't mean that in 5 years you just got to put them all in, because development could come or it might not, and it might not come in this exact area. So it's really a trigger. So if something, if something starts coming in over here in 5 years, and they say, hey, I want to develop here, you have a project now, and you have a plan on what you need to initiate to serve it. But up here, if it doesn't happen for the next 10 years, then you don't have to do that until that trigger initiates that project. So the next phase we look at is a 20-year planning phase. And that really, most of the 20-year plan was really concentrated up in that north area. So that would include additional sewer collection pipe and force mains and lift stations to bring service out. You guys have the rail spur that goes out here, and so to service those areas to the west of the rail spur, and then up there in the north area. So again, we are projecting a 20 years on here, but it's really based on what actually happens and when those projects need to move forward. So there's 2 main projects as part of that, or as part of our 20-year plan. And so it's really that north area, and then a potential to, talking with Brenda and your staff, looking at the central plant being decommissioned and potentially serving it with a new north plant. And Jeff and I are going to be talking a little bit more through those phases. So that's an overview of the capital improvement projects for the collection system. So any questions?
I think 2008 taught us a lot when we talk about master planning and, the old adage of build it and they will come. 2008 proved that wrong. So I think a lot of cities built their infrastructure banking on development coming, and it didn't happen. And we know cities, we could name a list of cities that ran into that issue where they built the infrastructure in the wrong location. They built it out south and it occurred up north. So when we talk about trigger point, I think that's extremely important, and I think Rochelle hit it home when she said when this happens or when this is coming, that's when you put it in. So don't get ahead of yourself if that's not happening. So, Rochelle just went over the CIPs, the capital improvement plans for the collection system, for the wastewater collection system under existing conditions to get you up to speed with a level of service or a 2-year design storm, and also the future growth projections here. That kind of ends our collection system piece, the wastewater linear piece. You guys have any questions about that? Because Jeff's going to come talk about some really fun stuff when he talks about facilities. So
You get another 0 or 2 behind those numbers.
a little bit bigger projects, but you got some big facilities out here. So
I guess with that transition, and this may again be a premature question, but when you're talking both about collections and facilities, you know, we've had folks in the past kind of talk to us about, you know, we should not have 3 plants, we should have X number of plants and those kinds of things. So I assume you're going to get into that, and that's going to overlay into, okay.
I think we'll talk a little bit about that.
Okay.
I think you're unique, as Rochelle mentioned, with your 3 different ridges in Sedalia that kind of causes you to do a couple different things. But, you know, I think Rochelle mentioned maybe moving that central plant to a north plant at some point in time may be an option. Now you've reduced down a little bit maybe, but we can talk a little bit about that.
Then you replace it with lift stations, right?
And you've got a lift station to take care of. Yeah. So potentially. I will say the hydraulic model that we used, and the model's used for the collection system, but it's also used to help predict flow down at the treatment plants. And it truly is a tool, and it's a tool that we developed. We calibrated it, we ran the model, but it's the model that you guys own. So that model is yours to use, and when you look at future flow conditions, or if we start metering after we do an I&I program, we can meter it and see how much we took out, and then we model again and say, hey, do we need to do more improvements or less improvements? So, but that model is yours forever, and what's great about it is you can use it for development, you can use it for growth, you can use it for decreasing growth, however you want to use it. But we're here to support it, but you guys own it. So I think Jeff's going to talk to you about facilities.
First time I've ever had to move a mic up a little bit. Good. So my name's Jeff. I love wastewater treatment. Have any of you all been to the wastewater plants? Mary, you have? Steve? Mm-hmm. Miss Foster? I can't pronounce your first name. Perfect. Rhiannon. So I love wastewater treatment. Steve does. The mayor does. My friend Ike here does. Our friends from Alliance do. I know Brenda loves wastewater treatment. But we're going to talk about that. The city has 3 wastewater treatment plants. You got the southeast, the central, and the north wastewater plant. And we've got this formatted in such a way that we're going to run through kind of the same information 3 times over. So we're going to start with effluent compliance, like the water that we test as it leaves the plant to confirm that we're okay and it's okay for the environment. There's a couple of parameters we test for there. And then we're going to look at kind of the existing facilities. We've got photographs of the existing facilities and kind of review their condition and how well they're doing just visually. And then we've got kind of planned improvements laid out. So the thing about the wastewater treatment is it happens just like our presentation here. So we do all the studying and analyzing of the collection system, and then we work into the wastewater treatment facilities. So we understand hydraulically, and I'll call it organically, the load, how much crud is coming our way, before we get in and really assess it. So we've got some pretty good ideas. I remember we had dinner together like last year, 2 years ago. Yes. So we go in and assess it, and then we identify the needs we have, and then we price it. So we don't have all that pricing developed the way Rochelle did for the collection system, but we're working on it, and we're getting there. So just wanted to give you a word of caution. So we're going to start with the southeast plant. As it's named, duly, it's on the far southeast side of town. So the big blue circle, oh my gosh, that's animated. It flipped by itself. So it's located on the southeast side of town, down by Route M and, oh yeah, Goodwill Chapel Road. And that plant, so the first thing up is a graph, and I hate this. I mean, honestly, grass, it's late. I'm kind of hungry. So these graphs indicate compliance. So the green line here is what we need to hit on a monthly average, right, Ike? Yeah, and then the red line just above it here is what we got to hit on a weekly average. So the weekly average, we can get a little bit ornery. On the monthly average, we got to keep our numbers pretty low. So this is a graph for BOD compliance, and BOD is biological oxygen demand or biochemical oxygen demand. Sorry about that. I was about to get busted. So biochemical oxygen demand, and what that is it's a measure of the strength of the wastewater. So if your BOD leaves your plant too high, one, you're out of compliance, but Ike, if it's real bad, what happens to the creek? What color does it turn? Yeah, it turns your creek black. It turns it septic if that BOD is too high. Thank goodness the Southeast plant here is like an all-star on BOD compliance. So far, so good. Next up, we got effluent total suspended solids. Now, I did TSS tests a few times in college, but I didn't do them near as many times as you guys do. But my understanding is you take a little piece of filter paper and a vacuum and you run your water through it, and then you know the dry weight of that filter paper before, and then you go cook that filter paper in the oven, and the difference in the weights is how much total solids gets caught on that filter paper. So it's a measure of like the solids that are leaving the facility. I'm going to show you some pictures here in a minute of the clarifiers of the Southeast plant. It'll tell you why sometimes these numbers get a little high. Brenda, am I doing okay? Okay. So sometimes those numbers get a little high depending on how good you're treating and how settleable your sludge is and all that good stuff. And then finally, ammonia. So y'all won't believe this, but I have 6 children, and they're amazing. I got a daughter in college. She goes to engineering school. She's lovely. And then I got them all the way down to like 5th grade. But they're wonderful. And if I set donuts and broccoli in front of my kids are going to eat the donuts first. So biologically, the way the bugs behave is they go after that BOD first, and then the ammonia. So the ammonia is like broccoli, the BOD is like donuts. So they're going to scarf down all that BOD before they hit the ammonia. So that's why we see some of these excursions on ammonia here, is you're nailing the BOD at the Southeast plant, but occasionally the ammonia gets a little bit out. And by out, I mean it's out on a monthly average basis. And the reason these things are like sawtooth like that is the limits are seasonal. So in the wintertime, your limits are a little bit higher, and in the summertime, your limits are a little bit lower. Now, Ike, if you have like a blow up on ammonia, what can happen? It kills fish. Killing fish is bad. So like downstream, you'll see a fish kill. Somebody will call that into the EPA or DNR, and it's a problem. I don't believe that's happened in Sedalia, but I'm just trying to paint worst case scenario for you on if BOD or ammonia are in bad shape. Oh, so this is the headworks. So the headworks, you have to walk down 2 flights of stairs to get to the bottom of it. And the headworks is where me and Rochelle like really interface. What happens is like when you get water coming down the creek, we got these bars. It's sort of like a comb, like I used to put through my hair. It catches all the big stuff, like the stuff that's maybe 1/2 inch and bigger. So if you're plastic or very, very solid or stringy, like these screens will catch it and it'll scoop it up and put it in that wheelbarrow. And currently what operations staff has to do is they've got to walk down 2 flights of steps, grab this wheelbarrow with all sorts of fun things in it, and then they have to wheel it over to a corner, and then you gotta hoist it up and dump that wheelbarrow in the trash can. We'll go over like some ideas that we have to make that a little bit better in the future. There's more efficient technologies, and there's technologies that require a lot less contact with what's coming down the sewer pipe. This is okay, so Brenda always tells me, Jeff, remember, that is a BMTS, a Burns and McDonnell treatment system. From the mid-1980s, mind you, so it's been a good value. It's lasted well over, 40 years? A little under 40 years. But what made the BMTS special is it had the clarifier integral to the aeration basins, which is a little bit of a trick to run. And when your equipment is kind of older and maybe not as operable as it used to be, the skimming on the clarifier surface doesn't happen the way it should, right? Ike is shaking his head. He's agreeing with me. So like this center picture here, I'll show you a clarifier later that looks good from like Central Plant. That's supposed to be clear water on top. It's like got a bunch of algae on it because these skimmers back here quit moving. They kind of seized up. So that's the condition in the summer. And in the wintertime, you end up with a lot of sludge that kind of pops to the top or some sort of filamentous that makes a foam. Am I right? Yeah, good. I'm passing my operators. Well, I'm an engineer. Operators know how to operate. Engineers can engineer, but together we can do really good if we can communicate. So this stuff here is not good either. If you get a big wet weather flow and you got all that, I'll call it brownie batter on top, and it flushes it out, you'll have one of those big TSS excursions. It's really horrible. Sorry. And then over here on the end is like the aeration basin itself, and that is where like, okay, so you go from the headworks, and you've got like what the bugs would consider food, and if you give the bugs food and oxygen, they eat and then they multiply. It's like college on a Friday night. So like the bugs eat and they make more bugs in the aeration basin here. So that's all the brown stuff in there. So the more bugs you have, the more they eat and the more food they can take on. So there's better technologies available now than what was available with the BMTS to aerate that material. So this is the kind of outline of the improvement needs. We're highlighting these clarifiers again. So we delineated with a big box over here where we put clarifiers in the future. And a clarifier is just a big circular tank where you can get all your biology or your biomass to settle to the bottom, and you can recirculate it back to your aeration basin so you can get your bugs cycled up to a certain age to treat different things. And as you get new limits, you need different bugs, and you can develop a population that's both young and old, or kind of middle-aged like me, to do things like eat the ammonia or eat the BOD that comes in. This is the, so a wastewater plant's sort of like a pet. It's going to have to poop, right? It's got a residual that comes out of it. So if you just continue to cycle those bugs over and over again from the clarifiers back to the head of the plant, you'll end up with like a really thick mess. And what you got to do occasionally is waste those bugs to a process for solids handling. And what we have on the right here is the existing belt filter press. And basically it takes maybe solids that are, you're probably running 1 or 2% to the belt filter press and then pressing out to maybe 15, 20% on a good day. You doing better than that? Okay, so these presses are still doing pretty good in terms of operation. Oh, absolutely. So like the belt presses, what they do is basically remove the water so that you can haul off cake instead of a bunch of water with your sludge. Initially, the sludge goes into a little tank like this to be aerated. You need a little more capacity to have so many days of sludge storage before you take it to this dewatering equipment. And we'll show on an aerial here kind of a photograph of how much additional capacity is needed. So this is an aerial of the Southeast plant. I'll just start from the start. This is that headworks area where the screens were that were really deep, where you got the wheelbarrows full of fun things that you have to hoist out. Not great. This rectangle here represents like a new headworks, where your screens are shallower. Basically, they'd be at the floor level with you, and you'd have a technology implemented where the screenings would not need to be touched by Ike or any of his people or any of the Alliance people. Yeah, auger it out, dewater it, put it in a dumpster, and then, yeah, you haul it off. Yes, Moberly probably has that technology. They're close. Yes. It's like a spiral? Yep. Yes. Those are both really good options for what we need to do here that would be way better than going all the way down the stairs and using the wheelbarrow. So, yes, Ike's making a good point there with this. And then, so let's keep it simple first. So these areas here that are the big red squares with the hashes through them, we're going to convert to aeration and then move the clarifiers out here. And these clarifiers are just great big circles. And you got a return sludge pump station like I was talking about earlier to take the sludge off the bottom of these guys, goes back to the plant, keep your bugs happy. The clear water decants off the top and then goes to your ultraviolet disinfection building here, and then it gets disinfected and discharged. And finally, I'll tell you on the liquid stream process, we would want to install an anaerobic basin. There's a new regulation coming out. I just went over BOD, TSS, and ammonia. They're going to start regulating phosphorus. So by 2033, plants this size will be mandated to have compliance with effluent total phosphorus. So phosphorus is something that causes eutrophication in lakes. Basically, you end up with oxygen-deprived conditions because you have a big algae bloom and it dies and it's real bad. Same thing happens in the Gulf of Mexico. So they're coming up into the states that are tributary to like the Missouri or Mississippi River and trying to attack what we would call biological nutrient removal up here. And then finally, sorry, last circle here that I didn't identify was the sludge storage basin. Caitlin, did I get all of it? Any questions on my first generic run through of all right. Amazing. Sir?
How much?
This is very feasible. So the biggest chunk of the work is right here. These clarifiers and aeration basin improvements, the stuff on the south side or the bottom of the page, that's lots of millions of dollars, and probably not single digit. The headworks is something that could be a standalone one-off project that could be implemented. And the sludge holding and belt press, that's also kind of a one-off project that could be done by itself. So to Brenda's point, you could do a one phase with the headworks, another phase with solids handling, and I would suggest doing the headworks first, because if you put in new dewatering equipment, you don't want to rag it all up with stuff that you should be screening out. And then this last phase, this is the biggest phase with the most dollars tied to it. You got to do all of this at once, otherwise none of it works. So we'll have our
When's the deadline? 2030?
2033. But on the phosphorus.
Phosphorus, but he just said everything, including the anaerobic basin has to be in.
Yeah, and I know that working with DNR historically on facilities and communities like Sedalia, I believe everything's negotiable. So it's likely, based on other improvements that the city's going to make, we could probably do something around affordability and phasing and dates to say, hey, we can't do this right now. Our rates will get crazy and everybody will move out. Well, I shouldn't have said that, but our rates will get crazy. This one's closer to 2.5. The peak well other flow though, Tom, gets way up there. Like when it rains and like Rochelle was talking about, you get all that water in the pipes, that storm water and that sewage, you get a pretty big slug down to this facility.
But the thing about this facility, we don't have any industrial in there. So it did impact on the processing and service component, and it's landed around people.
Yes, that's right.
It's not just a preferred method of payment.
Correct. The blending is allowed.
Blending right now. How long do you think it will?
As long as I say. Well, it needs to last longer. So what I've heard on blending, and here's my real answer, is they're going to eventually push water quality standards. So long as we have the ability to meet water quality standards, it shouldn't matter what's happening upstream of the end of pipe, in my opinion. And I think that's an argument that would hold. I think. Heck yeah, I told you I got 6 kids. I'm doing this for another 150 years. I agree. Yeah.
But it is feasible.
Very feasible.
And it's just a matter of all these pieces that you're hearing about tonight, they are high dollars, they are high ticket, and it's how
Mhm.
with the first community in the state that did a master plan, and DNR has been working with the mayor Senate on building both their wastewater and their water capacity, so that the community is not overburdened by rate.
Yep. That's correct. Did you have anything, Ike, you would? You know, the Southeast plant, in terms of, I don't think it's going to move a whole lot. Most of your growth that we're seeing is on the north side of town. 2.5, 3 MGD. Is that kind of the ballpark? Yeah. Yeah. So.
There's not any significant projected growth in these basins except for residential growth.
Yes.
According to the comprehensive plan.
Yeah. And that's where you can buy back some capacity and reduce your reliance on blending. And that's the argument that you take to the state is we're going to reduce our reliance on blending over time by buying back capacity in the collection system, which will continue to allow us to discharge from it's the big tank here. Basically, the raw wastewater plus stormwater goes into this tank, and then it blends with fully treated wastewater just before you go to ultraviolet disinfection, and then it leaves the facility. So the idea is that under a rain event, if you're 10-to-1 and your starting BOD is 200, your wet weather BOD is 20. Okay, so you got 20 milligram per liter leaving that tank, and then if this plant is doing a good job, maybe you have 10 or 15 milligram per liter leaving it. By the time you blend that out and run it through the disinfection process, it's relatively compliant with water quality standards. You're not way out. That's the idea anyways. That's what I think. Okay, are we ready to go central plant? All right, buckle up. Go to central plant. Oh man, it's animated again. It's so fast. I need to have Mercedes slow that down so I can speak to it. But the central plant is kind of on the north side of town, north and that's west. I have directional impairment. It's severe and acute. That's the intersection of 65 and 50. Is that correct? Kind of through the middle. So it's in that little quadrant up there. And the central plant, historically, so we've got less data on the central plant in terms of compliance data, but it appears the BOD compliance has been good historically. The effluent TSS compliance also has been reasonably good. Where we start to see some issues is with, again, ammonia. And ammonia is something that the state continues to move down. Same with BOD and TSS. Everything is going to continue to move down, or you're going to get more limits in your permit to address like total phosphorus. But ammonia is something that we're starting to see have some issues, and this speaks to the overall organic capacity of the facility. So the central plant, I wish we had an aerial, but we don't, but it's surrounded by these huge extraneous flow basins that capture and store stormwater during rain events, and the plant sits kind of on an island in between a creek and all these basins. So it's really tough to expand this plant to either address new capacity needs or new effluent limits. The condition of the existing facility, so the aeration system, the blowers and diffusers, the blowers flat out need to be replaced. That's kind of the heart of the process. You got to have air for the college students to breathe, to eat the bugs, to make more bugs. So the blowers need to be replaced, and then additional diffuser capacity or aeration capacity is needed as well. And then it would take a pretty substantial investment to address phosphorus in the future, this 2033 date. So I forget who, I think it was you, Mr. Mayor, that brought up, hey, what about consolidation, or Kelvin, I forget, consolidation of treatment facilities in the future. This is one as a candidate, given what needs to happen with the North Plant, which we'll get to that here in a minute.
The blowers and the oxygen issue. This is the plant that you've been reviewing for me because we have $2 million to do the upgrade. And it's putting the bank waiting to move the project forward. We've had a disagreement between Burnham and Henderson about the exact process that we need to make sure that is in that supply.
Correct. And I think it's pretty straightforward in terms of achieving more consistent compliance with new aeration and blowers. What we'd be talking about, these are the aeration blowers sitting here. And if Bob was here, we'd talk, but this is supposed to have something connected to it, and it fell off the day we were there. So, I mean, these are like your old car, where, like, you've driven it and driven it. It's sort of like the cars I give my kids. Like, I don't care if it gets wrecked, but we do care in this case because that blower is needed to give the bugs the air they need to breathe. So these blowers need to be replaced, and then out in the basin itself, you've got these diffuser racks that are located around the perimeter of the tank that blow the air into the tank. We need to add more diffuser racks, more diffusers to add additional aeration to the tank itself. And then finally, these two circles out here are the clarifiers. This is what we'd be planning to install at the southeast plant. What's happening at the central plant is you have a population of bugs here, and you refer to it as mixed liquor suspended solids. If that gets too thick and you get a rain event, the solids loading right to these clarifiers gets too high, and you end up with your sludge blanket going up and over the weirs, and that's real bad. So additional clarifier capacity would be nice at the central plant as well, but not sure that fits in the $2 million budget. We are pretty darn certain that we can replace the blowers and the diffusers in the tank in that $2 million COP budget.
But this plant was built in the 50s, 40s initially.
Yeah, especially this north part.
60s? Is this our oldest plant that we're operating? Mm-hmm. North is?
Anything else there, Steve?
So you were saying replacing the blowers, but not adding the clarifiers. Does that get us to the increase to the design capacity that we talked about?
I think you had talked about 3.03 MGD. Does it get us to the capacity?
Mm-hmm.
It would get us more compliant with the existing load. The 3.8 MGD, Caitlin, what was it? Sorry, this is Caitlin Prem. She's the smartest person among the smartest people I know. I won't tell you anything else about her because she gets embarrassed, but.
Yeah, the blower replacement and adding diffusers will just help with ammonia compliance. At the existing rate of flow, you really need that third clarifier to be able to expand capacity.
And I think that's where us and Olson might have had our disagreement.
Yeah. So ballparkish, what's the third clarifier cost?
That, Brian, if he was here, I would be okay giving an off-the-cuff number. It's well in excess of the $2 million that we have budgeted for the aeration system. Brenda, do you want me to go any further than that?
So when you guys have it all, when you could clarify another plan, because the problem we've got, I'm just going to be upfront about it, the problem all of us have to remember tonight, building is the number we give maybe 40% off the cost increase of cost period.
That's correct. And I mean, the clarifier essentially is a big concrete tank, but it's got a lot of steel or aluminum that goes in the middle of it for the clarifier scraper arms and mechanisms. And that's the numbers that they haven't really done much of this. They've done mostly
a lot of labor too.
Yeah.
The labor, I have a good problem. Actually, the numbers that they, in the city Lafayette, the numbers they put together, when I compare it with what they did for us, outstate in the last 12 months, the numbers in Kansas City are significantly higher than what we're getting in the bid results here. So we have a problem compared to what Kansas City is facing on the labor market. But that's because of the projects we've had. We've been able to pick up small construction companies from Tipton, California, and Odessa to do those jobs. And we've been fortunate. The question becomes whether there's going to continue to opportunities for them or when they begin to lose more staff and they can't pick up the jobs for us. So they seem some savings there.
Yeah. What's going to be wild, Brenda, is when they start to really deploy all the money that they're issuing and people in earnest begin doing projects.
They're saying that FEMA has the construction for highway starts, everything else is shutting down.
Yeah.
Because it will take all the construction companies just to do the highway work. So, and if we were talking 2021,
Go $1.5 million bucks.
Yeah, I'm just looking for ballpark.
Yeah.
Yeah.
Be my ballpark. Yeah. Yep. Does that help?
Mm-hmm.
Okay. I'll get you a real number later if you want it.
Yeah, I'm just,
Mm-hmm.
for example, one that was out that day, this report was where someone used during operator. It is the redundancy built into the system. So that blower is in place being set up, I hope, tomorrow or Wednesday. So they approved that on January, and that's when we get the blower.
Yeah.
All secondary lift station pumps are sitting on boats in a harbor waiting to be unloaded. And we are orders from the lease and as well as we have leads and so we've got lots that have gone on. We've never seen that thing operate as it was operating before COVID.
Yeah. Correct.
So I think once we get all pumps in, all the leads replaced, blower replaced, I don't know, sludge pumps, they are processing sludge every day. Nothing's happened today, right? Yeah, I mean, at Central Plant right now, we have enough pump motors, out. We have to check on condition every day. I've got at least 6 pumps out. Yeah, at least 6. 7. Yeah. So we got 7 pumps out. Most of them have been on order for November, December. The first pumps out of any of those actually delivered. So they were supposed to be delivered April 1st, and now we're telling them April 30th. So all we can do is ask you to allow us to order, and we're waiting on what will come in first. In the meantime, we're operating off mobile pumps, and however we can run the pipe until those become
out there to literally turn the pump up and down. Man, we keep going. 3 miles a day is what I walk.
So, it's a matter now of just getting those pumps in and getting them fixed. We were talking earlier tonight, we are not the only city with this problem. You need to hear that. You know, everybody looks at me for like, you know, the guy who watched 3 weeks ago about. I'm not going to ask him. But, we just need some, equipment to move it so we can get it installed. An example was different once we get some motors and blowers.
Yeah.
Use the rack. We'll find it.
Perfect. Okay. Oh my gosh. Okay, here we go. Phase 1. Actually, I think this is more than one phase. So we got the clarifier sitting here and the aeration improvements sitting here. So that's the central plant aerial with the improvements indicated. And then finally, what we were getting at earlier is consolidating central plant with the new north plant. So the north plant, Tina, you asked for like grades on plants. The north plant is the one, I'm going to switch this just a little bit, you've gotten the most value out of. So it's like the car that kept going. It's really an awesome value in terms of dollars per gallon that plant has generated for its lifetime. So central plant, sometime in the next, Brenda, we talked about 12 to 15 years, we would build a pump station and force main to take the contents of what goes to the central plant now up to the north plant, likely continue to leverage the wet weather overflow assets or the extraneous flow basin assets that were built there a couple of years ago. So, north plant, we ready for it? Yay, I'm almost done, I promise. So north plant is on the farthest northern side of town. It's off of, I feel like it's off of 65, but I can't read those roads from here. Georgetown Road, thank you. And it's a trickling filter plant. So what's nice about the southeast plant and the central plant is fundamentally they are okay for effluent criteria that are coming, but need some, I'll call them moderate tweaks to get them to work well. You can salvage a lot of the concrete structures there. The north plant is a trickling filter wastewater plant. Trickling filters are fundamentally different in terms of the technology used to treat the wastewater. Basically, I believe it's rocks. Is it rocks? Yeah. So the wastewater runs over these rocks, and these rocks will grow fur on them, sort of like a chia pet, and that fur is what eats up the waste instead of the big pool of mixed liquor and brown bacteria. So again, my analogy of donuts and children versus broccoli and children, the bugs are skipping the donuts here. That's a bad sign, and you'll see that it gets much worse later. So again, this is the effluent compliance at the north plant. This is the TSS compliance on the effluent side. So that is starting to really creep up, especially as we got into 2019, 2020. And that TSS compliance is a thing. And then this is where the state will really get after us. And this is where I believe, Brenda, we've got a schedule of compliance in our most recent permit on the north plant. And we'll see some more details on that. But lots and lots of blue dots above the green line is not a good indicator for that plant being able to take on any additional capacity or to treat any better than it does now. This isn't operations issue. This is fundamentally you got the wrong vehicle for the service that you needed to serve.
Recognizing that we're talking about land that was put into service in 1920.
Yes, ma'am. So dollars per gallon, it's way down there. Beautiful plant in terms of financials, but it's time that it gets totally replaced. And that's not something I'm saying at the southeast plant. There's many assets at the southeast plant that can be reused. The central plant, there are some assets there that can be reused. The north plant is not salvageable at this point. So these schedule of compliance dates, these are real. These are issued by the state of Missouri, and they're basically to say, hey, look, this is a real problem. Here are the dates that we need you to hit in terms of meeting these new effluent criteria. And what we need to do is work with the state to implement solutions in terms of capital infrastructure to make that happen. So the dates are on the far left, and then we work through different ammonia limits for daily max and monthly average. What we see is that monthly average comes all the way down to 1.3 and 2.7 for summer and winter time. Effluent ammonia compliance, which is like half on the summertime average that it is now. And then E. coli, there is no E. coli limit at the north plant. So the central plant and the southeast plant both have ultraviolet disinfection so that E. coli gets zapped. Basically, the light is at a very specific wavelength. It renders the E. coli unable to reproduce. They don't last that long, which is kind of wild, but they die off in like 30 seconds. So you got a reactor time of like 30 seconds. The north plant doesn't have that technology deployed. There's no chlorine. There's no nothing. So the water leaves the plant undisinfected. I'll leave it at that. So effluent compliance, based on the new limits, this is just a repeat of that same sawtooth chart for ammonia. You see out to the right here that effluent compliance gets even worse as those limits come down further. So the new north plant, beating this to death. The pieces that we're after, compliance. Okay, we want to be able to hit ammonia numbers and BOD numbers on a regular basis. E. coli, most of the plants in the states meet E. coli limits. Most of the plants in the states have ultraviolet disinfection, sodium hypochlorite, something to disinfect wastewater. And then while we're at it, if we're going to spend this much money, we want to be compliant with what's coming out in 2033 with total phosphorus, and make sure that we have facilities in place to take care of that, so you don't finish a construction project and have to go right back out and do another one. That would be wild. Condition, again, necessitates major capital improvements. And then the growth, the 20-year growth projection is 4.8 MGD just for that north plant and the north service area. If we add, I was doing some math earlier on my calculator for Caitlin, just to make sure that these numbers are right. So the central plant, I think the forecast is 2.7 MGD. So 2.7 and 4.8, 7.5. And you'll see here in a second how we phase in the north plant capacity that we need. Michelle, I was looking at my notes for the first time a few minutes ago, and it said you were supposed to jump in here, but I think I can do it. You want me, okay, I don't want to step on your toes. All right, she can be violent. Her husband's a wrestling coach? Yeah, I'm just afraid all the way around. Yeah. Oh, shoot, sorry. Thanks, Cliff. Okay, so the north plant sits right here currently. And what we're talking about is moving it to this new yellow square just a little bit to the north of the existing north plant. That property and exact location is not totally identified yet, so that's still a little bit loosey-goosey. And then there's new linear infrastructure, like from the central plant here to the left to the north plant, so you'd need a force main and pump station to get there. And then most importantly is this service area out to the east. Where we're looking at proposed lift stations, force mains, gravity sewers to get potential industrial, commercial development from this area conveyed over to the north plant so it can be treated. And so that area can be honestly opened up for investment and construction. Anything else there, Brenda?
Every time there's a grant opportunity, we apply in our head. There are funds out and we can ask for all that new and unique piping, including piping back to the old north plant. Something more for the long person. They're supposed to come out with actual grant applications May or June.
Yeah. So they've got a training, Brenda. I know you're signed up for it. It's either the 11th or 12th of May.
So hopefully they'll be willing to help us.
Yep.
And we get asked for the plan.
Well, can you say again for me what the time frame was for the projection to decommissioning the central plant in?
We're thinking 12 to 15 years. I think those are the same numbers I said earlier. Yeah. Yes, after upgrade. So maybe more closer to 20-ish.
Oh, okay.
So the central plant's going to stay for a good amount of time. The investment is worthwhile.
Yeah, that's where my mind was going. Thank you. Would the clarifier make sense if we were talking about 12 years? But if you're talking about 12 years after that,
yeah.
So if you're talking really about 20, then yeah, that makes sense. So,
yeah.
Okay.
Yeah.
Yeah.
Okay, I'll keep going. There's a number of different treatment processes. I'm not going to explain these in great detail, but these are two we looked at that will achieve the water quality we need. Some of the big factors we were looking at, I think, are on the next slide. Basically, we want to be able to expand the current wastewater capacity, both in terms of how much water you can get to it, and then how much loading we can treat based on whatever comes down the pipe. Meeting compliance needs, that'll be a new and great thing for the North Plant. We want to meet compliance needs for not just BOD, TSS, and ammonia, but also for nutrients and for E. coli. And then just improve the overall operations and safety for the staff. This shouldn't be a plant that you've got to babysit 24/7 with three guys monitoring pumps and mixers and controls to make sure everything works the way it should. And then the phasing approach. So this is a big deal. So the existing North Plant, I think I saw it gets maybe 1.1 MGD on an average day of 1 million gallons per day. And then we're looking at some fairly near-term growth over the next 5 years. We're able to capture the existing flow to the North Plant plus the near-term growth. So that initial investment at the North Plant would give you a 3 million gallon per day facility. So you'd have plenty of headroom there to bring in new growth and development. Following that, is that probably 20-year, we'll call it 20-year growth period. We would want to be able to double its size so that we can take on the central plant, build that pump station force main from the central plant up to the north plant and consolidate it. So then you take all the operations off of the central plant. You don't need to have that staffed anymore, and it's no longer an operating wastewater plant meeting effluent criteria every day. It's a pass-through. And then finally, and Rochelle had a really good figure earlier, a big purple area on the north side of town, kind of over to the east. There's lots and lots of developable acres and space over there. Another 3 MGD available in terms of mirroring that plant over one more time and getting some additional capacity there to take care of that growth. Finished.
So the plant would be designed scalable?
Yes. So the way we have been discussing it is to identify a piece of property that's big enough to take that initial 3 MGD and plop it down and build it. And then when needed, have the infrastructure in place between like electrical duct bank and piping and grading so that you could come over and just plop down basically the same tank right next to it. So that would give you 2 tanks at 3 MGD apiece. And then finally, when you need that third phase, you'd plop down 1 more tank, and you'd have 9. So it'd be 3, 6, 9. And then there's other facilities tied to it, like clarifiers or whatnot. But that's the idea in general, is to incrementally make that investment so you're not trying to do 9 million gallons a day all at once. 2 reasons. 1, financially painful to do that much facility. 2 is the biology doesn't like being oversized. It wants a tank that it fits. So that 3 MGD facility is actually best both, I think, financially and for the service of the bugs as well.
So give me the acreage.
Oh, did we do 15?
15?
Yeah.
Total for all
3
phases.
Yeah.
So it wouldn't hurt to have 20, Murphy's Law?
Be terrific. I mean, one of the things that we like to consider is like buffer, like if you could have some, I don't know, hedgerow, trees.
Okay.
Yes, sir.
Future property for, all 3 phases, is the shape of the layout or square, rectangle,
You ask an engineer what shape he wants for his wastewater plant. I have so many thoughts right now. Rectangular is fine, just not too narrow. What happens is if the shape is either odd or if it's too small, it locks us into technologies that are different than what we've got shown. What I was showing earlier is basically an activated sludge process versus a membrane bioreactor process. So if your property is small, and you see a lot of these like on the East Coast where you don't have a lot of property, you do a membrane bioreactor, and that's because you can run the bugs up a lot thicker or denser ahead of those membranes. And the membranes are a physical barrier. They almost look like these pieces of paper if they're on flat sheets, or like little straws. But highly complicated to operate, and lots of mechanical equipment and moving parts. So not something we want to do. So that's why we went to 15 acres and hopefully like a nice, call it broad piece of ground, that we could do something that is more traditional, that requires less mechanical equipment and less, it's actually fewer points of failure to do one of these more traditional facilities. And you're going to have more operators that know how to like go in and operate a more traditional facility. Sorry, Brenda, I went too far on the MBR. Correct. Yeah, and we came to that in a workshop a while back with the staff, that something with a little bigger footprint is actually better for the city of Sedalia based on that. And the availability of land, quite honestly, kind of pushes you, or doesn't push you, but it makes this more attractive. Just because the other one's footprint is smaller doesn't mean it's less expensive. They're very proud of the membrane technology. So you charge an arm and a leg for the membranes themselves, and then they have a finite service life. You got to replace them every 5 to 7 years. So it can be kind of a tough technology to operate and maintain.
So that layout is kind of rectangular, And when you duplicate it, when you do phase two, do you just,
Yep.
does it matter how
You
you
would
lay it next to it or above it or?
you would take these two tanks here
Uh-huh.
and you'd flip them and make another set of two tanks here.
Okay.
And then add a clarifier or another circle here.
Okay.
So, does that help, Kelvin?
Yeah.
Yeah, so just continue to like make more rectangles going to the right and then make more clarifiers up in here. We'd probably configure it a little bit differently than this one. This is, actually this is a duplicate of the Northwest Arkansas Conservation Authority. It's down near Bentonville. So this is an actual plant. We just have a 3D rendering of it. And so that's relatively scalable. Oh, that type of equipment, I like to make it a collaborative decision with the operator himself or herself to kind of look at different technologies and decide what's best. So centrifuges are great. They do take annual maintenance. Usually you sign a contract with somebody to maintain it. The centrifuges spin really fast. It's sort of like a high-speed dryer where your clothes sit in it and spin. We do a lot of laundry. And it flings all the water out. Centrifuges work that way. There's other technologies like the belt press you've got that have a whole lot of motors on them. Centrifuge, nice thing, it's got like 2 motors. Belt press has like 12 motors, I'm exaggerating, but it's got a bunch. It's got a bunch of pumps and it's got a bunch of different things that turn the belts. And then there's another technology called a screw press, but the screw press footprint is quite a bit bigger than like a centrifuge footprint. But again, it's got like 1 motor and it turns really, really slow. So that's something we would want to take a look at. In terms of cost, they don't deviate a whole lot from each other when you're talking about the grand scheme of a wastewater plant. So it's kind of operator preference and it's maintenance, yes.
And if you're looking at the plant, you want to keep operating for 50 years,
Yeah.
maintenance costs are quite expensive.
Yep.
So how many dollars are we talking phase one?
So we did put a price together on that. Cliff, am I okay?
Yeah.
All right. Just want to make sure. Yeah, you're not going to leave me here. Yeah, we put a price together on that. I think the phase one on the north plant was like, can I say it? I've said enough.
Mm-hmm.
It's $65 to $70 million is where we came up with, and I don't recall if that included some of the linear assets too.
It included the sewer from the north plant to get it to the existing north plant to get it to the new north plant.
Yeah, so a little run of sewer here to get it.
And we did prepare a topic for the pop-up grant funding.
And
So-
that's, we gotta have that really done next 3 years?
Pretty quick. Yeah. There's the compliance schedule from DNR, and then there's the schedule that Brenda doesn't like to divulge about other things that are going on that's going to demand wastewater treatment.
Yeah.
And the reason I say that, DNR cannot force the city to do something that we cannot get components for. I can't get an electrical panel for the lift station that we've already done. We've got construction, we've had it ordered almost for a year now, and they're gonna start construction next week, but we don't have the electrical panel, and they can't guarantee.
So what's the timeline that we gotta build in? What's the design time, the construction? I mean, I've not built one of these, so how long does it take to build one?
It depends on how you deliver it, and we can talk about that. But I forget. We had 2 schedules, and I thought it was 3 to 4 years. So, yeah.
So that's the truncated schedule, it's the one that I first mentioned here.
Yeah.
Because if we truly want to use that deadline, that first one, say, and we miss some of the constituents or concerns, we also have a copper supplement limit that we have problems with at the Warren plant. We're currently doing a plan, you hire an engineer to design it. You went out on an RFP to hire a construction contractor. And then there is a period of time when you do lots of things back to the engineering firm. And the city is very much in the middle of all of it as a control factor. Under design build, you actually hire an engineering firm that has a construction branch so that the engineering and the construction are almost simultaneous. So that's kind of what I'm getting.
I think the advantages of that also, Brenda, are the timing of ordering equipment, right? You have the supply chain issues, and one of the issues you can identify early on are some of the mechanical equipment or even the electrical panels that Brenda brought up. Those are things that can be ordered. If you have a design builder on board early, you can order some of that stuff a little bit quicker. So your time frame, construction time frame is decreased, not only due to the fact that you're starting to build, but also you're starting to order the material and equipment early too. So that kind of gets you a little bit closer to that compliance state that you're talking about.
But the real cash outlays come when you start the construction. So how much time frame, either way you do it, whether you do design bid build or a design build, you got that design period where.
Go ahead.
So what we'll do is we'll go through a approach where we design efficient prices, which is way different than the design and efficient price.
Yeah. Yeah.
So when we get design sufficient price, that we run a 10-12 month time frame, and then we start procuring equipment. And then as we're procuring that equipment, we continue design based on the equipment selected. To get to the point that we actually break ground and begin construction. Depending on how the project is phasing out and what people we're in, we can structure it in certain packages to do the earthwork, the concrete work, mechanical piping work early on. So that design and construction occurs more parallel. The way that we help ourselves a little bit with permitting too is there's a finite set of information that the state really looks at when they're looking at it and reviewing it. We produce just that, and then we go get our permits and construction. That's what you're after.
I think it's accurate. Yeah, I think the phase one, phase two Jeff's talking about is you are working with that design process, but you're also working with the contractor in the same sense, right? So you're looking at construction, not just designing it, you're looking at the construction pieces of it, you're looking at the construction material at the same time. So collaborative process of design build. So.
And the other piece that I will mention is, Burns Mag, traditionally, we've been in Missouri for over 120 years, done consulting engineering as well. In the last 15 to 20, we've really developed our construction capabilities. We do about $2 million in construction, we do about $2 billion in engineering. And the beauty is what we can do, especially through a master plan, is bringing in those construction assets early on. To understand where your real budgets and real pricing are going to be. So when we set a budget and master plan, that's the number we are going to hit when we go out to actually build the project.
So you do guaranteed max too?
We can do either format. So there's guaranteed maximum price and this one. So the way we typically execute.
Well, I mean, design build guaranteed max.
So you do a guaranteed max or lump sum?
Yeah.
Absolutely, two different ways.
Two different ways, two different methods of payment for the design builder. So we can do it either way. With the guaranteed maximum price, every time we submit the application, you get like a third-party binder full of backup information that may be. But what you're after with that is every unit quantity, every hour, every piece of third, every yard of concrete, every kind of rebar. Goes into a big file, and then you have to audit and review that, confirm it. But then there's what we said, you get paid for that. The other way we do it is through phase one, is where you build up. But it looks like that, I promise. We built up a very transparent price, so you see every nickel and dime, and every piece that goes into the price between hires, whatever.
Well, that's design build, so, yeah.
Goes into it, and then you see that final price, and then the price is locked in, and then we would convert it to one time, and there's a lot less administrative effort on the back end as we go with it. Does that make sense?
Mm-hmm.
So, just, there's two ways to payment, either cheap.
But we can, okay.
Yeah.
So we build up our price based on, that's a really good question, Brenda. So we would need to submit, and you used to do finance, so I can't be yes or no through this answer. Not that I would ever be yes or no through an answer. But the prevailing wage, you're gonna wanna see the rates that we're paying out to everybody. So we submit that with our pay application, we have to. Yeah, you would still need to get the certified payroll. So I mean, like, on the design state build, that's not a guaranteed match. You're basically doing that on some price on big facilities projects. But I think it's gonna look real similar to what you see on design state build. We got a little bidder, but you don't know any of the backup in that little bid, but you get a certified payroll, a percent completion every month. So I think, just not being a finance guy, that's how that would work.
So I kinda wanna be clear, I mean, we make that decision further down the road because we don't know what the economic condition's gonna be. I just wanted to know what our options
That's
are.
a great point. You know, when we're going through a phase one process, that's where we're working up a cost for you. So at the end of that phase one, we're gonna tell you what the guaranteed price is, whether it's a lump sum guaranteed maximum price, whatever it is. You'll see the dollar amount before dirt starts moving.
But we're talking, how many years out? We don't know. 3 or 4?
I think we estimated through a design build process 3 to 4 years. To completion, yeah. To completion.
Yeah, well, but I mean, a lot can change before we even build these contracts.
First thing you gotta do is decide if you have any questions about the site. But all of that has to fall into place first. For this project to work the way we need it to, fit in with everything that's going on.
Yeah. So, yeah, and that's really what I'm trying to get in my mind is the budget and the chunks. Okay, so we got to budget enough money to get us to that concept stage, or what I would call concept.
Phase one stage.
Yeah,
Absolutely.
where
Right.
you're before we can get to a number of how much money do we need to go borrow to make it happen.
We're
So.
talking about $65 or $70 million, you know, even if, traditionally, if it was designed digital, the engineering could be some percentage of that. I forget what we talked about, but something like 6 to 8%, and that initial run for phase one of that total capital value, which is a pretty big number. We could design for graph.
Okay, say that. I'm sorry. Yeah, but that's your total engineering.
Yeah.
So to get to where we know what the number is to budget, what's that number?
Did we set 65?
Phase one, how much is a phase one?
Yeah, that, probably half of that, so 4%.
But that gets you to about a 30% to 60%. Gets you your number.
They have to design enough to be able
Yeah.
To get the pricing.
Yeah.
So that's right about.
Yeah.
to, you're seeing that at 30%.
There's different pathways, right? You can take it to a 30% and say, okay, this is what the price is gonna be. But we're gonna say, okay, this is only 30% design, so this is just an estimate. We can take it further to a 60%, it's gonna cost you a little bit more to get to the 60%, but we're more confident in those numbers too.
Yeah.
So when you give you those numbers, you're gonna have some budget numbers to work with.
And the other thing I'll tell you is like, so I can give you a number right now in terms of what it would cost to do the plan, but my contingency number is gonna be really big. Right?
Yeah.
The more progressed we did our design, the more we know, the less contingency we can provide. So if we wanna have a balance in terms of contingency relative to percent complete, we wanna just have that discussion and figure out where we wanna be. So you can spend as little as you want to design, which is large. Spend a little more on design.
Mhm.
I think, you know, we talked about a trigger and trigger events that make something happen too. If there's any place in our plan that we're gonna get that trigger event pretty quick, it's gonna be up there on that, I think in that area, North 65 area, so.
Okay, so if I did the numbers in my head, roughly 2.5 million for the first 10 months of the project.
Roughly, yeah.
Okay. And then the big money starts.
That's right.
Anybody got anything else? Any other questions?
Got any good news?
I'd encourage, yeah. So there's two different funding mechanisms we know of right now out there, and that's the ARPA and then the IIJA, I believe is what they're calling it now, the bilateral. So there are two funding mechanisms that are out there that they're promoting right now, and I believe the city's put in for both of those funds. There's also some grant money that could be out there for starting some of this. It's one thing we've looked in. You know, I mentioned earlier the I&I. You asked about the private I&I, and I said there weren't any grants. Well, there is grants possibly for doing total I&I. So it could be, you know, the public side I&I removal program. I think they've got a grant out there for $1 million, Jeff? $1 million for doing that. So that's an application that if the city's interested in looking at, we could look into doing something like that. So there's a combination of some different sources.
Would that fit in that pilot project for that central zone?
I'm wondering, that
When are you not careful?
potential to knock it out of something.
That's absolutely right. So there's, yeah, the DNR ties your hands in some cases to other projects and money.
But you'll look.
I always do, but
Okay.
I'm after that $65 to $70 million number first. Also, on the private side, USDA does have a grant program for homeowners of a certain age and a certain income. I think a lot of what we're looking at, we may have with funds. It's putting that information out so that people will find it.
Would that be those two gals locally that we worked with on the, same two people? Okay.
The biggest part of a private I&I, we call it a private I&I program, is really public relations and is educating. And, you know, it's a make it or break it when you start looking at a private program, is if you don't have a good public relations program, it's not going to go very far. So a lot of education goes into that type of program. So
A lot of what you saw, the yellow zone in the southeast, the city did a lot of work on the public side. That yellow, we believe, is 95%
private side.
property.
So the good news is we're almost done with the master plan. So, and we're developing the overall cost for the.
You did come up with something.
Got to end on a good note, right? So we're almost done with it. You know, I think you've got a copy of our presentation. We're always open for any questions. I can't tell you how much we've enjoyed working with the city over the past year, working on this. You know, Jeff mentioned we built the plant down here. We've been around in Sedalia since 20. I've given Brenda some of our old pictures of some of our old projects we did back in the early 1900s. So from Burns and McDonnell, we've enjoyed it and love getting back here and working with you guys. So if you guys ever have any questions regarding the master plan, the wastewater one, and in fact, I guess I'll be here in 2 weeks presenting the water master plan, so I'll be back. But in the meantime, if you guys have any questions, we're always open for it. So.
Thank you all.
Thank you.
Appreciate it.
Thank you, guys. Appreciate it. All right.
Hang up.
So this work session's adjourned.
Thank you all.
Exciting stuff, huh?
We got Bob. We got Steve.